to the show. Amit and Steve, how are you all doing? Let's start with you, Amit. Please introduce yourself.
Hey, hey Anna. Hey, folks, everybody on the call. Uh, I'm head of product for SageMaker Geospatial, and nice to be here to talking to everyone about this new offering.
Yeah, I'm excited to hear from you. And Steve, you're actually from a customer. You're not from AWS. Tell us about yourself, please.
Well, hey, everybody. Steve Renter. I'm the Director of Business Innovation with ProAg. We are a small, mid-sized crop insurance company in the U.S. One of about 12 of us approved to write crop insurance in the States. And my role is all about introducing new technologies into the organization to help hopefully solve some problems.
Very cool. I'm excited to hear more about ag tech and how you all are using geospatial capabilities in SageMaker. My family, actually, my cousin is in ag. He raises pigs. So small world.
Right on.
Cool. All right. So Amit, we're going to be talking about this new geospatial capability that's been added to SageMaker. But before we even get into that, do you want to kind of give the audience just an idea of what SageMaker is, what they should be using it for, and how it makes working with ML easier?
Yeah, absolutely. So SageMaker is a fully managed service to help data scientists, machine learning engineers, data engineers, or even business analysts, anybody who's looking to really get started and to build out, specialized models. It's a fully managed service that takes away all the infrastructure work from you so that you can build, train, and deploy models. And we, SageMaker Geospatial is adding one more layer to it to make it easy for geospatial data scientists, geospatial analysts, or geospatial data engineers that want to build, train, and deploy models using geospatial data.
Great, awesome. I see Michael Leando in chat too. He dropped in chat. He's an Iowan and a huge fan of ag tech. Michael's a longtime friend of the shows here on AWS On Air. He was just on a show I run, Step Up Your Game Day. So hey to Michael. Now with SageMaker, like I said, I got a little bit hands-on with it, especially with Jumpstart. But we're talking today about geospatial data. And before we get further into those capabilities, I wanted to ask, first off, I think it's probably pretty obvious to most people what geospatial data is, but maybe not everyone has an extensive idea of examples of geospatial data, right? I think everybody probably knows GPS data, satellite imagery, that type of thing, but there's way more to it than that. And then also I wanted to ask about what are the challenges of working with geospatial data with machine learning, right? Why does it need its own special handling here?
Yeah. Let me present some slides to get, make it more tangible, what geospatial data looks like, feels like, and then we'll talk about what the typical workflow is and what are the key challenges that we see.
I set you up perfectly, didn't I?
Perfect. Yeah. So largely we categorize geospatial data into two categories. First is aerial and satellite imagery. Think about all the visual and non-visual information that's captured using aerial or satellite vehicles. These images are captured at the Earth's surface, very similar to the red, green, blue images that you capture from your iPhone, except they are much more cooler. They are captured through aerial vehicles, through drone images. All of that qualifies as sort of aerial and satellite imagery. And then we also have some information that's captured through LiDAR and radar. For example, what's the height of a building? What's the height of a mountain? And you can capture all of that information through some of these specialized sensors. In geospatial sort of world, we call this, broadly as raster data. And then customers use petabytes of this data to extract meaningful information and store it as vector data. For example, often these images are used to extract road network information. So there's an image on the right where you can see how all the roads in a particular area would look like. And map data also consists of point of interest data that expresses the neighborhood around you. So if your favorite restaurant, your gym, gas station near you, all of this consists of map data. Some amazing trends that we were hearing from our customers was that this geospatial data was becoming much more easily available over the last sort of half a decade or a decade. because prices to launch a satellite dropped to less than $1 million, from like tens of millions of dollars to less than $1 million. That's been game changing. And over the last decade, sort of nearly every device that you get in the market today is capable of emitting location data. So you're seeing map data emitting from your phone, from Alexa, from car, your fridge, everything is emitting location data. And this data was becoming much more easily available, but still not accessible for machine learning. And ranging on some of the studies that you see across the market, you'll see 60 to 80% of data today contains geospatial component. Think of all the pictures that you take today.
I have to call this out too. I had the exact same reaction. My fridge is actually good that I know where my fridge is, because often it's running, right? Like, how to catch it, right? Isn't that so true?
Yeah. What if it moves? You can figure it out pretty quickly.
Good thing I put that AirTag on it. Good. Anyway, I'm actually, and this is kind of funny too. Not that the thing I just said was funny, because it wasn't, but I'm most familiar with geospatial data because I watch a lot of hard-hitting science documentaries, like The Secrets of Skinwalker Ranch, which anyone in our audience probably is cringing right now, maybe. But they talk a lot about this, right? They're measuring what's going on in this very mysterious ranch with things like LiDAR, right? Which is ground penetrating radar. And like you said, Amit, like a lot of these things are more readily available to consumers than they ever were, right? Because that's what they're doing. They're coming out and they're bringing these tools. Drones are probably another thing that we haven't talked about that's generating a lot of these this imagery.
Drones are becoming extremely popular with the satellite prices dropping. You see new data providers coming in. The data is becoming so, which was very concentrated, is now available across the board. Fridge is like the theme of the day. So all this data is becoming easily available. And from the studies that we saw, 60 to 80% of this data had geospatial component that we were seeing customers were using today. However, only 10% of the data was used for sort of machine learning.
Wow.
Our conversations with the customer. And that was like really low, especially given how accessible machine learning tools are and how easily this data is, abundantly produced and easily available. So we started digging deeper to understand what does geospatial machine workflow looks like and what are the key challenges.
Can we pause before we get to that? I want to ask Steve, what are you seeing in your industry in ag? What do you see in geospatial data used for there?
Well, it's actually kind of interesting. So for years, crop insurance companies and ag companies in general have been good at collecting data, but not so great at exploiting the data for business intelligence and things like that. For us specifically, geospatial data is somewhat new to us. It's kind of a new area that we're really looking to enable our organization with to be able to leverage for intelligence and decision making and things like that.
Makes sense. Yeah. And I know we're going to hear more about ProAg here in a little bit too. So I wanted to give a little tease there. All right. Sorry, Amit, back to you.
Yeah, absolutely. So as we started digging deeper, we learned this is what a typical geospatial machine learning workflow looks like. Very similar to a typical ML workflow, except in this case, you are collecting the data from one of the data providers that exist in the industry, either from free data available from NASA or European State Agency, or from one of the commercial providers like Planet Labs, Airbus, Maxar. Or if you have your own drones flying, then you have your own proprietary data coming in, or you might have just GPS coordinates that you are collecting from your fleet as a business. So all of that data was very hard to query and get into the same format, because if every data is in different format, then querying it becomes much harder. Doing ML becomes harder. So getting access to that data, standardizing it was challenging. And if you're acquiring data from one of the data providers, then you often have to negotiate licensing, and go over these negotiations for a couple of months before you can start experimentation and even know whether ML is the right path to pursue. So that was one of the big challenges. Second, Once you get access to this data, this is very large scale data. Unlike most text data that you work with, the volume here is huge, and you need clusters running, around the day. Some of our customers that are tracking deforestation across the planet, oh my God, they just need machines running for days, and they're trying to do analysis like on a year worth of data. So they need two things. They need large scale compute. Managed large-scale compute, but because managing compute is not where they accrue most value as a business. And second, they need specialized functions that can work with this data. So for example, if you're working with satellite images, the first thing you're going to do is either mask clouds, which basically means you're going to turn clouds into black pixels, or you're going to try to infer what's behind the clouds so that you can start to make decisions, because those are the pixels that do not really accrue value to your machine learning model and may even introduce some inaccuracies. So that's some of these sort of transformations that you would want to run. And if you're
you need large scale Photoshop basically, but you don't want to do that yourself.
That's a great way to put it, right? That's a great way to put it. And if you're working with sort of GPS traces, then you need more than Photoshop, because now you want to know what's the address corresponding to this GPS trace, or which segment was it collected on, so that I can actually make some inference about the drive on which was collected. And most of the APIs that we saw in the market were, catered towards developers with one GPS coordinate that you could. So we saw there was a need for providing capabilities which could transform tens of thousands of coordinates. And then once you have all this data cleaned up, now you want to build and train a model, which could take weeks. So what we have done, we started to look at the gaps here. We saw there were some models that were used across each use case, and in some cases, customers needed specialized label data to fine-tune the model or to build a model that was very relevant for them. Like, Steve's use case, he needs a model for agriculture. Insurance companies need models to identify the height of a house, if there's a pool in the house and there's an overhanging tree. And there's no one provider that can, sort of provide you all of these things.
Yeah, I liked what Charles had to say here. One of the use cases, determining, the effects of weather conditions and on product sales, right? So I could see how that very much would correlate with crop growth, right? Like you may use this to determine what crops to grow based off of what weather is incoming, right? If you have a drought coming, you might want to, get some more crop resistant to drought, like planted for the upcoming weather. I like too, Amit, too, you point out removing the clouds to see, but I also am interested what's hiding in those clouds, which aliens.
All the UFOs, we don't talk about that.
I talk about it nonstop. And,
AM wants to believe.
I do.
I have the poster, but I should give you this poster.
I think I've earned it. I think I've earned it.
Yeah, I think so.
Yeah. I think Steve can probably share an example here of how they are leveraging sort of, weather data to trigger some of these workflows. I'll hand over to Steve to share something.
Yeah. Cool, Steve. Do you need me to share your screen?
Yeah, please.
You got it. You are up and running.
All right. Thank you so much. And thanks for the lead in a minute. So as I kind of talked about before, I want to set a little context about our business, because we are a relatively small organization, less than 400 employees across the United States, minimal experience in GIS, imagery, and ML, which means we don't have an office full of data scientists sitting by the wayside waiting to do this work, right? So we're trying to figure some of this out, and in a lot of ways we're kind of behind the curve on this. Because the reality is, geographically, we cover a very large footprint. I mean, we write business in 40 plus states across the United States, which is a very large geographic area. And you're thinking hundreds of thousands of farm fields of varying sizes and shapes. We really need the tools to be able to first and foremost, I think, really manage the data. So if you want to go to kind of the next slide. There we go. So kind of thinking about the technology needs and really what we thought about coming into these conversations. As Amit said, we're talking about massive amounts of data. We really want to leverage the power in satellite imagery that's readily available out there to us today, whether it's the open source stuff with Sentinel or higher resolution, higher frequency with Planet or other sources. it's a lot of data. It takes a lot of compute to process, and as well as storage, if that's a part of the equation. And ultimately, we need the tools to be able to do all that work and then try to get the data to our customers, which is really where it becomes something of value. Along with that, of course, is not just storing. You don't want to just bring data in and store it. You don't want to build custom ML workloads on top of that to monitor the crop and do analysis on the crop during the growing season. Or really, a lot of our business is retroactive. So when there's a claim situation, our adjusters have to know what happened in that field 2 or 3 months earlier, which is really where the power of the historic satellite imagery comes into play. But and we've done this several times, just straight up NDVI imagery in the hands of somebody in the field, while it's visually interesting, it's really hard to infer what the value of that information is. So you need ML models to kind of translate that data into something useful for the folks in the field. They don't have to understand how it got there or what it means, but it helps them with their decision making. And then really third on there is, of course, we don't want standalone ML systems. We want services that we can consume and integrate by our existing applications or new applications in the organization, again, to help both in the front end and on the output side to really make that process kind of end to end.
Very cool.
Next slide. Yeah. Was there a question? I'm sorry.
No, I was going to ask, it seems like it sounds like you're taking automated steps based off of the predictions and inferences that are generated from this. Can you give us some example, like what might some of that automation be?
Well, that's where we're really early in this process. We have a lot of theories, and we have strong beliefs that there's value here. So we're trying to build out the processes and systems to be able to deliver it. Like I said, is part of the complexity is the nature of our fields, and that we're talking about 10-acre fields all the way up to several thousands of acres and hundreds of thousands of these fields. So it's small broken areas across the United States versus large metropolitan areas. So it's the sheer number of fields that we have to monitor under different parameters. So if you're talking about a cornfield in the Midwest, you have a different interest or set of parameters for that imagery versus, say, an apple orchard out in Washington, right? It's different growing seasons, different cycles, and everything else. So it needs to be configurable, and it needs to be automated in the back end because, like I said, we don't have the staff to sit there and push keys all day. They need to, our goal really is we want to have this data readily available for underwriters, for actuaries, for claim staff, whoever needs it. And they don't have to know where it came from or how it got there.
Very cool. This is great. This is like some of the key power of ML, across many industries, is to augment the abilities of just a few people to do a whole lot more, whether it would take them way more time or just not being something they could do.
Mm-hmm. Absolutely. Yeah. It's we believe there's so much potential here with this, and we're just scratching the surface. And obviously there's a lot of other organizations in ag tech in general who believe the same thing. We think we have an advantage here because we do have a direct relationship with the customer, with the farmers out in the field, and we believe that we can provide a better service and a more cost-effective service by doing that work ourselves. And ultimately, if we can help our customers, the farmers out in the field, grow a better crop at the end of the day, that's really what it's all about.
Very cool. Now, Amit, I know you've got some actual visible maps with some that have been looked at from some ML models as well to show us as well. Steve, anything you'd like to wrap up with here before we move back to Amit?
No, I think. I'm as excited about this stuff as you guys are, and so my job now is to try to push Amit along on that roadmap to help deliver the stuff faster.
That's right. I love it. All right, so Amit, back to you. Let's see some of this stuff in action. Let's see.
Yeah. So now that we understand the gravity of the problem, from our customers, we launched this capability that we'll walk you through in the next steps. at reInvent in preview, and that makes it easy to build, train, and deploy models using geospatial data. So you can easily and readily access open data sources. You can enrich and transform this data, and then you can accelerate building the models. We'll see how we do that in action in the next few slides. And you can then visualize these predictions in the map. And as of 19th May, this functionality is now generally available. So you can even start to run production workloads and get started on this, just like Steve. Okay, cool. So let's take a look at, by the way, I love geospatial because of some of the key use cases that you'll see have life impacting decisions. So here is a case study that we work with our data scientist who's working with first responders to help them understand and make decisions during a flood, to see how first responders can navigate the situation, help rescue people.
Yeah, this is particularly of interest, I would say, to both Anna and me, because we both grew up in Houston, Texas, which is often hit with hurricanes.
Lots of flooding, very frequent flooding, unfortunately.
Yeah. And people who have been in these areas, they can resonate really well with the problem statement here. So what SageMaker does is basically offers you access to, first, to build a model, you need access to geospatial data. So the data is readily now available in SageMaker. Rather than spending days trying to aggregate information, you can simply select the area you need. So in this case, we select Midland, Michigan. We can start to see what the area looks like with Sentinel-2 images. You can adjust the time frame to now look at the images before and after the flood. You can start to clearly see how water has affected the area and how much damage it has caused. And so in this particular area, this is great information to sort of, get an overview, but to actually make some decisions on the ground, you need to zoom into this area. So Sentinel-2 offers 10-meter resolution, so you can see each pixel sort of represents 10 meters on the ground. This information was helpful to get overview of the entire area, but when you want to make concrete decisions, you want much more high resolution imagery. So with SageMaker, you can now bring in high resolution imagery. For in this case, let's say we add high resolution imagery from one of the providers that we support, Planet Labs. So now you can see what's the condition on the ground and which area is completely submerged. You can see what it was before the flood, and you can run your own sort of road extraction model to see where the roads were in this area prior to flood. And this is the information that first responders need, because on the GPS, this is essentially the information they're seeing. They don't really have the information of which areas are submerged. So as a data scientist, you can visualize, you can understand what the first responders, the information that they have, and then you can start to augment that information with, which areas are submerged, where the first responder should be going, and so on. So now you can run the exact same model on the flooded area. So now you can see clearly which roads are still intact and which ones are submerged. And this is the information that a first responder needs on the ground to make some decisions. And you can send this information to the first aid team. You can see these are the areas that are, submerged. These are the areas that are blocked. Some roads which are still accessible, but a warning area before anybody sort of heads on those roads in this particular case. And with the visualization tool, you can sort of communicate this information by coloring them differently, so that the first aid team can clearly understand what the information they are seeing right now. So in this case, green color roads are safe to drive. Red color roads are submerged in water. The red stop signs are sort of indicate the area where you can't drive anymore. And the warning sign tells you, that the road is still accessible for driving, but not completely accessible.
Yeah, I mean, this is not just important information for first responders. I mean, massively important to them as well, as obviously, but it's also important to anyone who's out in the middle of one of these storms in general. Like, you see this growing up in a place like Houston. You've got roadside signs that are saying "Turn around, don't drown," because people will drive into water not thinking that it's as deep as it is. Right? It's extremely dangerous. So this is awesome. This is incredible information.
Yeah. And then often first responders not only need this information, they need the information of, where can they drive people, where they can take them to a safe area. And often in this particular case, you will have, temporary sort of helipads showing up and so on. So you can also now bring point of interest data on these maps. So in this particular case, you will see, we'll add point of interest data that shows you where the airfields are, where the medical center is, where the community center is, where is the temporary helipad. So now with this information, the first responder team knows that, MRCM airfield, which could have been a great place to rescue people, is now submerged in water and not safe, rescue and bring people there, or for people to not even go there, as you mentioned, right? This information is also helpful for people. So you can safely navigate them to community center, which is easily accessible from, from the main road, as well as to the temporary helipad. So that now people who are trying to get out of that situation, they know exactly where to go, how to go, and for first responders on where to navigate these people. Incredibly powerful use case and how we are seeing our customers are using these tools today.
Yeah, I love it. Yeah, I'm sorry to push you, Amit, but we are running short on time, and just want to make sure that we cover everything that you need to. Anything else that you'd like our audience to know? Where should they go to get started? We got about a minute left before we got to move to our next segment.
Yeah, so we have our official website where you can learn more about the product, and you have a developer guide. If you are want to get your hands dirty, you can simply directly jump to the developer guide and get started. We also have a Jumpstart solution. You can scan these barcodes where we have an agriculture use case that you can go and try. So Jumpstart solutions are interactive live notebooks. You don't need to really, they already come with sort of pre-written code. So you can just execute the code, get the feel of the product, and start to modify it, play around with it.
So if you're a data scientist, not necessarily a developer, you would want to start with the Jumpstart and get started with that?
Cool. Data engineers, data scientists, both can get started with Jumpstart solution. They both have the same components.
Very
awesome.
Cool. All right. Well, Amit, Steve, thank you both for joining us so much. This was incredibly informative.
Yeah, thanks a lot for inviting. And
yeah, thank you. Thanks for having me.
All right. Well, hope to see you again sometime in the future. But until then.